What if I told you the universe has an expiration date, that at some point, trillions and trillions of years in the future, everything we know, the stars, the planets, the galaxies, and even you and I, will simply cease to exist? It sounds like science fiction, but it's a reality scientists have been seriously studying for decades. The universe isn't eternal, and today we're going to discover together not just when it might end, but how this cosmic demise could happen. Welcome, cosmic explorers, to another journey through cosmic frontiers. I'm your guide on this expedition into the mysteries of the cosmos, and today we're going to tackle perhaps the deepest question of all. What will be the universe's ultimate fate? Prepare to discover 3 apocalyptic scenarios that will make you rethink our existence. The big freeze, where the universe dies of cold. The big rip, where reality itself tears apart. And the big crunch, where everything collapses into an infinitesimal point. And at the heart of this cosmic story is a mysterious force called dark energy, which may be the final arbiter of the destiny of all that exists. We're building an incredible community of cosmic explorers here on the channel, journeying together towards 1,000 subscribers, and each one of you is part of this voyage of discovery. So buckle up, because we're traveling to the end of time. Imagine the universe is like a gigantic party that started 13.8 billion years ago. In the beginning, everything was super lively. The Big Bang was like the moment the music started playing and everyone began to dance. The first stars were born, galaxies formed, and for billions of years, it was a spectacular cosmic celebration. But like every party, there will come a time when the music stops, the lights go out, and everyone leaves. The question is, how will this cosmic party end? To understand the universe's fate, first we need to get to know the main characters in this story. The first is something you're already well familiar with: gravity. It's like that person at the party who always wants to pull everyone closer, forming little groups and trying to keep folks together. Gravity is constantly trying to gather all the matter in the universe, pulling stars, planets, and galaxies toward each other. On the other side, we have the expansion of the universe, discovered by Edwin Hubble in 1929. It's like an invisible force that's constantly pushing space outward, making galaxies move away from each other. Imagine someone inflating a gigantic balloon with dots drawn on its surface. As the balloon grows, the dots move further apart from each other, even if they're not moving on their own. But wait, the story gets even more interesting. In 1998, 2 groups of scientists, led by Saul Perlmutter, Brian Schmidt, and Adam Rees, who won the Nobel Prize for this discovery, made an observation that shocked the scientific world. They found that the universe's expansion isn't just continuing, it's accelerating. It's like someone stepped on the gas pedal of a car that was already moving. This mysterious acceleration was attributed to something scientists call dark energy. And here's a fact that's gonna blow your mind. Dark energy accounts for about 68% of the entire universe. That's right. More than 2/3 of everything that exists is made up of this mysterious force that we don't even really know what it is. It's like finding out that most of your house is made of an invisible material you never knew existed. Now, depending on how this cosmic battle between gravity, expansion, and dark energy plays out, the universe could have 3 completely different fates. Let's explore each of them, starting with the scenario scientists consider most probable based on our current observations. The first possible fate is called the Big Freeze, also known as the heat death of the universe. This is the most melancholic ending of all, like a song that slowly fades out until only silence remains. In this scenario, dark energy continues winning the battle, causing the universe to expand faster and faster. Galaxies move so far apart from each other that a time will come when, if you look at the night sky, you'll see only darkness, except for the stars of our own galaxy. But the tragedy doesn't stop there. As the universe continues expanding and cooling, stars begin to die one by one. It's like a city where the lights go out house by house, until everything is dark. In about 100 trillion years, a period so long it is impossible to comprehend, all stars will have consumed their nuclear fuel and gone out forever. To give you an idea of this timescale, if the entire history of the universe until now were a single 24-hour day, this distant future would be like waiting over 2 million years. It's a time so vast our minds simply can't process it. But even after all the stars die, the story isn't over yet. Massive objects like black holes will continue to exist, devouring any matter they find along the way. However, even black holes have a fate. They slowly evaporate through a process discovered by Stephen Hawking, called Hawking radiation. The largest black holes in the universe will take about 10 to the power of 100 years to completely evaporate, a number with 100 zeros. At the end of the Big Freeze, the universe will become a cold, dark, and empty place, with a temperature just a few billionths of a degree above absolute zero. It will be a cosmos populated only by subatomic particles wandering alone in the infinite void, never meeting each other. It's poetically tragic. The universe that began with the most energetic explosion of all time will end in the deepest silence possible. The second scenario is even more dramatic, the Big Rip or Great Tear. If the Big Freeze is like dying of old age, the Big Rip is like being torn apart by an uncontrollable force. In this scenario, dark energy not only continues accelerating the universe's expansion, but becomes increasingly powerful, like an engine that not only speeds up but exponentially increases its power. Imagine dark energy as a force that wants to separate everything from everything else. At first, it can only separate distant galaxies, which are already pretty far from each other. But as it gets stronger, it will start to separate closer galaxies. Eventually, it will become so powerful that it can overcome even the gravity holding our own galaxy together. The process would happen hierarchically, like peeling an onion in reverse. First, galaxy clusters would separate. Then, individual galaxies would start to break apart. Next, it would be the turn of stellar systems. Our solar system would be destroyed, with planets being ripped from their orbits and flung into the void of space. But the destruction doesn't stop there. Dark energy would keep getting stronger until it could overcome the forces holding planets themselves together. Earth would literally be torn to pieces, its rocks and oceans scattered through space, and the process would continue down to the most fundamental scales of matter. In the final moment of the Big Rip, not even atoms would survive. Dark energy would become so powerful that it could overcome the nuclear forces holding atomic nuclei together. In a fraction of a second, all matter in the universe would be reduced to isolated subatomic particles, floating in a space expanding faster than the speed of light. Calculations suggest that, if this scenario is correct, the Big Rip would happen in approximately 22 billion years. That might seem like a long time, but it's only about 60% more than the universe's current age. If cosmic history were a 2-hour movie, we'd currently be around 1 hour and 15 minutes in. And the Big Rip would happen when the movie reaches its end. The third and final scenario is the Big Crunch, the gravitational collapse of the universe. This is like the Big Bang in reverse. If the universe began with an explosion, in this scenario it would end with a spectacular implosion. For this to happen, gravity would eventually need to win the battle against the universe's expansion and dark energy. Imagine the universe as a rocket launched from Earth. If the rocket doesn't have enough speed to escape Earth's gravity, it will climb for a while, slow down, stop in mid-air, and then fall back to Earth. In the case of the Big Crunch, the gravity of all the matter in the universe would be strong enough to slow down cosmic expansion and pull everything back. The process would begin almost imperceptibly. After billions of years of expansion, the universe would stop growing and slowly start to shrink. At first, it would be like watching a slow-motion movie. Distant galaxies would stop moving away and begin to approach each other again. As the universe continued shrinking, things would start to get interesting and eventually terrifying. Galaxies would begin to collide with each other, creating spectacular mergers that would light up the cosmos. Our galactic neighbor, Andromeda, which is already destined to collide with the Milky Way in about 4.5 billion years, would be just the first of many cosmic encounters. As the universe continued contracting, the temperature would start to rise dramatically. It's the opposite of what happens during expansion. When something compresses, it heats up. The cosmos would become increasingly hot and dense, reversing the processes that happened after the Big Bang. In the final moments of the Big Crunch, conditions would become extreme beyond our imagination. Stars would be torn apart by intense gravitational forces. Atoms themselves would be crushed down to their fundamental components. Eventually, all matter and energy in the universe would be compressed back into a singularity, a point of infinite density, just as we believe was the initial state before the Big Bang. Some scientists speculate that a Big Crunch could be followed by a new Big Bang, creating a cyclical universe that expands and contracts eternally. It would be like a gigantic cosmic heart, beating through eons of time. But this is still highly speculative, according to our current understanding. Now, which of these three scenarios will actually happen? The answer lies in the hands of our mysterious protagonist, dark energy. It is truly one of the most enigmatic forces in the universe, and the fact that we know practically nothing about its fundamental nature makes it impossible to predict the cosmic fate with certainty. According to our current observations, dark energy appears to be a constant property of space itself, an intrinsic characteristic of the vacuum. If this is true, and if it continues to behave as we observe today, then the Big Freeze is the most probable fate. The universe will continue expanding, cooling, and becoming increasingly empty and dark. But what if dark energy isn't constant? What if it's changing over time, getting stronger or weaker? Different behaviors of dark energy would lead to completely different fates. If it gets progressively stronger, the Big Rip becomes possible. If it weakens significantly, or even changes its sign, transforming into an attractive force, the Big Crunch becomes an option again. Scientists are working intensely to better understand the nature of dark energy. Space missions like the Hubble Space Telescope, set to launch in the middle of this decade, were specifically designed to study this mysterious force. They will map the distribution of galaxies across cosmic time, measuring with unprecedented precision how the universe's expansion has changed throughout history. Other projects, like the Vera Rubin Observatory, which will begin operations soon, will observe distant supernova and other cosmic phenomena to track the universe's acceleration. It's like we're retrying to understand the behavior of a gigantic engine by observing its performance over time. One of the most fascinating theories about dark energy suggests it may not be a force or substance, but rather a modification of the very laws of gravity on cosmic scales. Perhaps Einstein's general relativity, which works perfectly on smaller scales, needs adjustments when applied to the universe as a whole. It would be like discovering that the rules of physics we know are just an approximation of more fundamental laws. Other scientists propose that dark energy might be connected to extra dimensions of space that we can't directly see or detect. Imagine our three-dimensional universe is like a sheet of paper floating in a dimensional space. Dark energy could be a manifestation of forces that exist in these hidden dimensions. There's also the intriguing possibility that dark energy is dynamic, changing its properties over cosmic time. It could be going through phases, like a cosmic climate system that alternates between different states. If this is true, the universe's fate wouldn't be fixed, but could change depending on which phase of dark energy we're experiencing. Regardless of which scenario comes to pass, one thing is certain. We, human beings, won't be here to witness the end of the universe. Even the fastest scenario, the Big Rip, would happen 22 billion years from now. To put that in perspective, our species, Homo sapiens, has only existed for about 300,000 years. All of recorded human civilization spans less than 10,000 years. The 22 billion years until a possible Big Rip is such a vast period of time that it's impossible to imagine how many civilizations could arise and disappear in that interval. But here's something that might blow your minds. Even if our species survives for just a few more million years, which would already be an extraordinary feat, that would still represent thousands of times more time than our entire recorded history. And if we somehow managed to persist for billions of years, we'd develop technologies so advanced that perhaps we could influence the very fate of the universe. Imagine civilizations so advanced they can manipulate dark energy, control the expansion of space, or even migrate to other universes. It's pure speculation, of course, but history teaches us that what seems impossible today can become reality in the future. Our ancestors could never have imagined that one day we'd be able to observe galaxies billions of light years away or send probes to other planets. The study of the universe's ultimate fate also teaches us something profound about the nature of existence. We live in a cosmos that had a definite beginning and will have a determined end. This makes our existence simultaneously insignificant on a cosmic scale and extraordinarily precious. We are complex structures of atoms that, for a brief moment in cosmic history, developed the capacity to contemplate their own origin and destiny. Think about this. You are made of atoms forged in the heart of stars that died billions of years ago. These atoms organize themselves in such a complex and improbable way that they can not only exist, but also think about their own existence and about the fate of the universe that created them. It's an extraordinary cosmic circularity. the universe contemplating itself through us. Meanwhile, scientists continued their tireless quest to unravel the mysteries of dark energy and determine what the true fate of the cosmos will be. Every new observation, every more powerful telescope, every more refined theory brings us a little closer to the answer to this fundamental question. It's one of humanity's greatest intellectual adventures, comparable to the great geographical explorations of the past. But this time we're exploring not new continents, but the very limits of space and time. So, cosmic explorers, we've reached the end of our journey through the possible fates of the universe, recapping the most fascinating points of this exploration. First, we discovered that the universe can end in three dramatic ways. The Big Freeze, where everything slowly cools and fades out. The Big Rip, where reality itself tears apart. Or the Big Crunch, where everything collapses back into a singularity. Second, we learned that a mysterious force called dark energy, which makes up 68% of the universe, will be the final arbiter of this cosmic destiny. And third, we understood that even without knowing which scenario will come to pass, the simple fact that we can contemplate these possibilities makes our existence extraordinarily special. But perhaps the deepest reflection we can take from this journey is this. In a universe that had a beginning and will have an end, every moment of consciousness, every scientific discovery, every act of love and creativity represents something truly precious. We are cosmic witnesses to a golden age of the universe, when stars shine, planets orbit, and life flourishes. We live in the best possible moment of cosmic history, after the universe has become complex enough to generate life and consciousness. But before expansion makes it too cold and empty to sustain complex structures. Now I want to hear from you, cosmic explorers. Which of these universe fates impresses or concerns you the most? The slow fading of lights in the Big Freeze, the violent tearing of reality in the Big Rip, or the dramatic collapse of the Big Crunch? Leave your thoughts in the comments. I love reading your perspectives on these cosmic mysteries, and often you make me think of angles I'd never considered. And since we're talking about the future of the universe, I want to know, what cosmic mystery would you like me to talk about in the next video? Supermassive black holes, the search for extraterrestrial life, the multiverses, or maybe something completely different that sparks your curiosity? Leave your suggestions in the comments, because this channel grows and evolves along with our community. We're on an incredible journey towards 1,000 cosmic explorers, and each one of you is fundamental to this expedition for knowledge. If this video expanded your horizons on the universe's fate, join our crew by clicking subscribe and the bell icon so you don't miss any discoveries. Like this video if it made you reflect on our place in the cosmos, and share it with someone else who is also fascinated by the mysteries of the universe. The more cosmic explorers we are, the deeper our journey of discovery will be. In the next video, we're going to dive into another phenomenon that challenges our understanding of reality. So prepare for another adventure through the limits of human knowledge. Until then, keep looking at the stars and wondering about the mysteries yet to come. The universe is full of secrets waiting to be discovered, and we're just beginning to scratch the surface. Thank you for being part of this journey, cosmic explorers, and we'll see you at the next frontier.